This is the first law of radical. We call it product law or product rule, which states that if we have a radical expression with this index n, and this is your radicand, if your radicand can be expressed into factors for which one can be simplified with the index, you can simply break it into separate radical expressions of the same indices, and then the factors of your radicand will become your two new radicands. Now we are going to show that this is true. Of course, let's not forget that AB is a factor or your radicand with factors A and B. And your n here is what you call as your index. So to show that this is true, let us start by understanding that again, our radicand can be factored by A or B, probably except for 1, because 1, any times any number is the number itself. Now, take note that this is under a radical expression with index n. There is an important concept of radical expressions. Once you see a radical expression, it's actually a fraction or an expression with fractional exponent. And this can be transformed in this manner. Your entire radicand, AB, raised to 1 over n. 1 over n as an exponent will give us a radical expression of index n. Now, earlier our AB is the radicand. Now it becomes the base of this exponentiation, and your index n earlier becomes the denominator of your fractional exponent. Now, according to the power law of exponents, once you have here an expression or a series of coefficients raised to the same exponent, you can just simply apply the power law stating to raise the same the first factor to a to the power of n, still to be subjected with the multiplication with b, now raised to the power of 1 over n. We are distributing, that's the term, to this exponent 1 over n to all of the terms here. And take note that this is power of 1, power of 1. Power law tells us to simply multiply. So 1 times 1 to the power of n is 1 to the power of n. And 1 times for our b times 1 to the power of n is also 1 to the power of n. Now, from here, we can now return from a expression with fractional exponent into a radical expression. Take it earlier that 1 over n tells us, as an exponent, tells us a radical expression with index n being the denominator of your fractional exponent. Hence, we have here nth root of a to the power of 1 times nth root of b to the power of 1. Or you can just simply remove that power of 1 there, nth root of a times nth root of b. Now, take note before I will continue. This also has an exponent of 1 here. That's why it becomes 1 over n. I forgot to mention that. But anyway, this tells us that the nth root of AB raised to the power of 1 is equal to the product of separate radical expressions of the same index n, but they are now separated, or we have now separated the factors of a radical expression, or the radicand of a radical expression. Now again, this is all about properties, laws, and theorems. Please subscribe now.